Welcome to the session on simultaneous equations. In this session, we're going to solve simultaneous equations using the graphical method. By the end of the lesson, students will be able to plot two linear equations on the same coordinate plane, identify the point of intersection, and interpret the intersection as the solution of the simultaneous equations. We will begin with the linear equation review. Suppose we're asked to plot y equals x plus 2. It is enough to find 2 points and plot them to draw a straight line. So the points that we have taken are x equals minus 2, and when x equals minus 2 we have that y equals minus 2 plus 2, which is 0. So we plot minus 2, 0, as shown on your screen. And we can also take when x equals 0, y equals 2, or 0 plus 2. Or we can take when x equals 2, y equals x plus 2, which is 2 plus 2, which is 4, and plot that. So on this occasion, we've plotted 2 points, minus 2, 0, and 2, 4. We only need these 2 points to draw our straight line, like so. However, the third point can serve or does serve as a way of checking that we've done our calculations correctly. And indeed we have, because 0, 2 has the line passing through it. We will now take a look at simultaneous equations and how to solve them graphically. Two equations are called simultaneous when they are true at the same time. When are the following two equations true at the same time? Y equals x plus 1 and y equals 3 minus x. Let's find their intersection point graphically. Let's begin by plotting y equals x plus 1 first. When x equals minus 2, y equals minus 1, because we have minus 2 plus 1. So we can plot this point. Here's minus 2 minus 1. Now let's plot one other point on this line. When x equals 2, y equals 2 plus 1, which is 3. So let's plot 2, 3 as well. We now join these points to form the line. This is the line y equals x plus 1. Now for our other line, we're now going to plot y equals 3 minus x similarly. When x equals 0, y equals 3 minus 0, which is 3. And that's this point here, 0, 3. Now for the other point. When x equals 4, y equals 3 minus 4, which is equal to minus 1. So we plot 4 minus 1 and join the points to form our line y equals 3 minus x. The two lines intersect at a single point. Let's find the coordinates of this point. So where do the lines meet? The x-coordinate is 1 and the y-coordinate is 2. So the lines meet at 1, 2, as shown. We can check the solution by substituting back into the original equations. So let's check in y equals 3 minus x. The left-hand side equals 2. It's just y. And the right-hand side equals 3 minus x, or 3 minus 1 at this point. And that also equals 2. In y equals x plus 1, the left-hand side equals 2. It's just the y value. And the right-hand side equals x plus 1, which is 1 plus 1, which also equals 2. And therefore, the point 1, 2 satisfies both of these equations. Now let's take a look at another example. When are the following two equations true at the same time? Y equals 2x plus 1 and y equals minus 2 minus x. Let's find their intersection point graphically. Let's plot both of these lines. Similarly to the previous example, we're going to find 2 points on each line and join the points to form each line. So when x equals minus 2, we have that y equals 2 times minus 2, which is minus 4, plus 1, which equals minus 3. So here's one point on our line y equals 2x plus 1. Let's now find what y equals when x equals 1. So when x equals 1, y equals 2 times 1 plus 1, which is equal to 3. So we plot 1, 3 on our graph, as shown here. And we join these points, and this gives us the graph of y equals 2x plus 1. Similarly, for y equals minus 2 minus x, when x equals 0, y equals minus 2 minus 0, which equals minus 2. So one of our points goes here, 0 minus 2, as shown. When x equals minus 3, y equals minus 2 minus minus 3, which equals 1. So we plot the other point, minus 3, 1, on our grid. And now we can join these 2 points to give us the graph of minus 2 minus x. These two lines intersect at a single point. Let's find the value of this point in order to solve these two equations graphically. So where do the lines meet? When x equals minus 1 and when y equals minus 1 also. So they meet at the point minus 1, minus 1. Again, let's check that this solution is correct. We're going to substitute this value back into the equations to check that the values hold. So in y equals minus 2 minus x, the left-hand side equals minus 1. And the right-hand side equals minus 2 minus minus 1, which equals minus 1. In y equals 2x plus 1, the left-hand side equals minus 1, it's just y. And the right-hand side equals 2 times minus 1, which is our value of x, plus 1, which equals minus 1. So for the first equation and the second equation, we can check that the solution is correct. Let's now take a look at some examples of some special cases. The first example relates to when lines do not meet. Consider y equals 2x plus 1. Here's the line of y equals 2x plus 1. And here is the line of y equals 2x minus 3. Can you notice something about this? These lines have the same gradient. So notice the two values which are all circled. They're all the same. So this is the gradient and it's the same for both of the lines. And therefore, the two lines are parallel. And therefore, they never meet. And so have no solution. Let's now take a look at another special scenario. This is when lines coincide or are the same line. So let's take a look at this example. Y equals 2x plus 1 is drawn as shown here. But the line 2y equals 4x plus 2 is actually the same line, even though it looks different. And we have many examples of this, but this is just one example. So these lines are actually the same and have an infinite number of solutions. Now pause the video and have a go at these exercises. Press play when you're ready to view the solutions. Solutions are coming up shortly. Now pause the video and have a go at these exercises. Solutions are coming up shortly. Before we finish, check that you can plot two linear equations on one coordinate plane, use different colors to distinguish graphs, identify the intersection point, solve simultaneous equations graphically, and recognize cases with no solution and infinitely many solutions. If you can do this, you're ready to continue. This brings us to the end of this session. Do attempt the exercises in your textbook related to this topic. Thank you very much for listening.